Okay, let's talk a little bit about scientific notation. Scientific notation is a system where you have a decimal number expressed as a product of a number times 10 raised to a power. So to do that, you're going to move the decimal point and leave one digit to the left of the decimal place, not 2, not 3, just 1. And then you're going to move the decimal into the right position by putting a 10 to a power. Be careful with the sign. A negative exponent is going to be a number between 0 and 1, so it's going to be a small number. A number equal to 1 but less than 10 is going to have 0 for an exponent. A number 10 or bigger is going to have a positive exponent. So let's look at a few examples of that. And so we got 0.00235, 230,000, 120.7, and 0.04370. And so we're going to take a look at each one of those. So looking at it here, I want the decimal point there behind the 2, so I'm going to move it 1, 2, 3 places. And so I'm going to write 2.35, and I'm going to have 10 raised to the third power, but is it going to be positive or negative? I moved this to the right, so it's going to be negative, but also it's a number between 0 and 1. And a lot of times it's easier to remember between 0 and 1 instead of to the right or to the left. 230,000, the decimal point's going to be right there. We're going to move it 1, 2, 3, 4, 5. And so it's going to be 2.30, we'll say, times 10 to the 5th, positive or negative. I moved it to the left, so it's positive. Also, this is a rather large number, bigger than 10, so it's positive. 120.7, I'm going to move that decimal point 1, 2. So I'm going to say 1.207 times 10 to the second power. And again, it's positive because it's bigger than 10 and I'm moving to the left. Last but not least, 0.04370. I'm going to have to move that 1, 2 places, but I'm moving it to the right instead of to the left. So I'm going to say 4.370 times 10 to the second, but it's not going to be a positive 2. I moved it to the left. This is a number between 0 and 1, so it's going to be a negative 2. Okay, let's talk a little bit about mathematical operations using scientific notation. If we got addition and subtraction, it's a little bit more difficult because you're not necessarily adding or subtracting the same places because you've got powers of 10. Sometimes it's better maybe just to run that through the calculator or convert it to regular numbers and then add. Either way, if you look at these numbers, for example, you see there's a -2 and a -3, and you've kind of got to work on that to make sure the decimal places line up. If you multiply or divide, you're going to add the exponents, and sometimes it's easier to do that multiplication, even though I've written that first one in a standard format, 5,000 times 35,000, in terms of scientific notation and adding the exponents, especially if you're not doing it with a calculator. You divide the exponents, or divide the coefficients and then subtract the exponents if you divide two numbers in scientific notation. And so it does work out. So let's look at that on paper then. Now work through those problems. So we've got these two numbers in scientific notation. Sometimes it might be better to say 0.002 252 plus 0.00375. If you're adding or subtracting, that way it's easier to keep the places lined up. Either that or run it through your calculator to get the answer. Regardless, we're going to get 0.02895. And so we're going to tend to round that to the thousandths place, which will, or excuse me, the 10,000ths place, since that's the smallest place on that number. This goes to one more place. We'll talk about that a little bit later in the course, but we're going to tend to round that to 2, and then that 9 is going to round up, so that's going to kick that up to 290 is where we're going to tend to round that. You round an addition and subtraction based on the least precise place in a number. So this one goes to the 1, 2, 3, 4. The thousandths place, this goes to 1, 2, 3, 4, 5, or the 10,000ths place. So we're going to round to the 10,000ths place. 1, 2, 3, 4. Let's see, 1, 2, 3, 4. These are larger numbers, so we got 1,577 minus 258. And now you can see a little better where to subtract. And so you're going to say 1577 minus 258, and you're going to be 1319. And both of those are to the ones place, so that's where we're going to round there. Okay, let's look at these numbers. Now you could just multiply this out, but if I do that in scientific notation, we're going to have 5 times 10 to the third times 3.5 times 10 to the 1, 2, 3, 4. So times 10 to the fourth. Now we multiply 5 times 3.5, and that's going to give me 17.5. And then add the exponents, so you're going to say times 10 to the 7th. But that's violating one of the rules that we've got. I don't want to leave it there. I'm going to have to move my place 1 over, so I'm going to say 1.75 times 10 to the 8th to get the number right. Looking at division, you're going to divide the numbers and then subtract the exponents. So 2.5 divided by 7.5, you would get 0.33, and that's a repeating decimal. We'll just go to 2 places, times 10. Now we're going to subtract those exponents. So -3 minus a -4, or -3 plus 4 is going to be a 1. But that's not where I want to leave it, right? We're going to have to go to here, move it 1, and so we'd have just 3.3. You can say 3.3 times 10 to the 0 power, but when you get anything to 0 power, it's 1, so that kind of goes away, and you just say 3.3.